There we go. So our very last section of the year. We're looking at the applications. Yeah, this is our last new section of the year. We're done after today. Everything else is review. It'll be good. So 9.8, applications of logs. Everybody's full attention. We're going to be using two separate equations. We're going to be using the compound interest formula. This you have used before or something like it back in Math 1. You either use this formula or you use this formula without the n, whereas essentially you're compounding once a year. N is how often you compound your interest. P is the initial amount. R is the annual interest rate as a decimal. As a decimal. Do not use it as a percent. How do you spell decimal? E-L-A-L. A-L, thank you. As a decimal. We almost never do math with actual percentages. We always switch it decimal or out of 100, make it a fraction. Time, T. The 1 right here, they don't say it, but this 1 represents the initial amount. The amount that you're starting with, we're wanting to take that amount and grow from there. Does that make sense? So we're adding the interest rate onto that 1 that represents the amount we started with. The other formula right here, I've mentioned a couple times that I really wish everybody would eventually take calculus, whether it's in high school or college. I'm going to show you in just a little bit where this one comes from. And this formula, you guys get to use it. We don't derive it because to find it, you use calculus. And using calculus on that original formula is where the E comes from, that 2.71 going on forever. You'll see in just a minute, we're going to look at a pattern. And if you followed that pattern through to its conclusion, you would find E. So let's go ahead down here, though, and start with the basics. If someone has $800 and invests that in a bank or somewhere at a rate of 5% annually, how much would the investment be worth if it was compounded just once a year? So real fast, this means the principal, the initial amount is 800. The interest rate is 0.05, right? Not 5%, 0.05. That 0 is important, extremely important. The time period they're telling us is 10. And the number of times it's compounded is just 1. So once a year. We're just going to plug all these pieces in and see if we can get an answer. Now, a side note, these are not necessarily real world applications at this moment, as far as 5% interest is unheard of right now for investments. If you had, let's say you go get a summer job, you save $800. If you go to invest that in the bank, you would be lucky to get 1% right now. It's super, super low. Good if you're borrowing money, bad if you're trying to save money. So here, let's go ahead and try this though. Again, it's foreseeable that in the next few years, we could get back to 5%. I remember like in high school, interest rates when I was in high school were around 3 to 5%. If you could get a certificate of deposit for those percents. It was not unusual. If you go back farther, in the 80s, interest rates were even higher. People were borrowing money at 18% interest. We'll talk about what that means and what it looks like. But for now, let's try this one, kind of the middle of the road, 5%. So the amount we have, $800 times 1 plus 0.05 divided by 1 raised to the 1 times 10. I've put parentheses in here to make sure I know what order of operations I should be doing. If I see this on your test, you're getting full credit, okay? But I'd really like you to be able to figure out what that is, because don't you want to know how much your money is worth after 10 years? So let's try it. Let's put it in a calculator. If you need a scientific calculator, go grab one. Hopefully we have enough back there. I'm going to check real quick how many were missing. I know there were a few that stopped working. Did anybody already grab a calculator? Oh. One. Go grab a calculator. I would avoid, unless they are the only ones left, avoid the little square ones that are down. Oh, the ones that are like 23, 24, 25. And then some of them, again, if you get one and it's not working for you, go back and switch it. I'm a little worried these two. The 30XA will work, but you won't be able to see everything all at once. You have to put it in step by step, and it will, if you trust it, do whatever you do. You'll just need to put it people at the end, you won't be able to see it all at once. Whereas most of the others do it like 30X2 or whatever, 2XA or something. Those will show you everything all at once. Go ahead and grab a calculator, and let's see if we can put that in. Actually, I'll do it with that same kind of or the simulator that I used last time. The exponent. Okay, use division. Division. So everybody, as you're putting this in, oops, let's get this up here. As you're putting this in, I want to see 800 times, I put the time symbol in there just to be safe, times 1 plus interest rate 0.05 divided by 1, right? The fraction bar comes from just division, divided by 1, raised to these. So look for an exponent key on this calculator. It says y to the x. For a lot of you, it'll be just that little caret. It'll be this symbol right here. That's raised to the, put parentheses after that, because we've got two things that need to be in the exponent. 1 times 10. Get it all there, hit equals. And that's what you should get. So that would be our answer, rounded. Okay, everybody, how do we round? Cents, 2 decimal places. So there are a few of you with calculators that don't show everything on one line. If it's a true scientific calculator, you should be able to put it in. It should work. I know that, I think, Ethan, you've got one of them, and Emily, same thing. Were you able to get this answer by putting it in step by step? Okay, it should work. Let me see if I can grab one and I'll put it up on the screen. Are these? Let me try this. So the recording won't get this one. Okay, and this is what you would do if you have an iPhone. Everybody, real fast, if you have a calculator like this, put this in like so. Again, even if this isn't your calculator, keep it quiet so everybody can hear. 800 times parenthesis, and it'll, when you hit that parenthesis key, it'll go to a 0 and say, okay, whatever you're going to type in is going to go in the parenthesis. 1 plus 0.05 divided by 1 and the parenthesis, and it'll tell you, okay, that's 1.05. It'll give you your answer. Raised to the, let's see, on this one, it's the y to the x, raised to the parenthesis. And notice up at the corner, it's telling me I'm working in the parentheses right now. 1 times 10 and parenthesis equals. and it will give me the right answer. I just have to work in blind faith that it's remembering everything as I'm typing it in. And it will. It'll do it as long as you put the parentheses in the right spot, type it in like any other calculator. It will operate in order operations. It'll give you the answer. You just can't see it all written out the way the other ones will. So after 10 years, our $800 is worth $1,303. Not bad. Go ahead and put the decimal there as well. So this is $1,303.11. If I put an answer up here, you put it in the calculator, you didn't get the same thing, ask myself, ask Emily. We'll see if we can figure out what's going on with your calculator. Now, the problem we just did, that is math 1. Like you did literally that almost exact same problem in math 1. Let's try, what if instead of it being once a year, the bank pays you once a year, what if they pay you a quarter of it every 3 months? So 4 times a year, they give you a quarter. Let's try this. Same exact formula, but with n is 4. So A is equal to 800 times 1 plus 0.05 divided by 4. So again, the only change here is that n is 4 instead of 1, raised to the 4 times 10. Everybody put that in your calculator. You should get very close to the same answer, but not exactly the same. It should be a little bit more. Yeah, so just watch for the round. Oh, then yes, I should have rounded that one. Like 4. We can discuss that another time, not right now.
Bruce Lee. Bruce Lee. Who is Bruce Lee? Yes.
Yes. So I would say that I made a mistake on the last one. It would have been 1, 2 on the last one. And so this should be nice. I was going off of memory. So thank you again for catching that. So a couple things. We did have a little issue with rounding. The previous problem, everybody, this should actually have been 12.12 for the last one because of rounding. And this next one, we should get $1,314.90 because it's 895. 895 would round up 1314.90. So just by being paid 4 times a year instead of once a year, we got an extra $11. It's not a ton, but it's measurable. Like we can easily see that that's different than what we had had originally. This next problem tries to take us through what would happen if you kept compounding more often? So quarterly, okay, the question says, an investment with a rate of 7% is compounded at different frequencies. Give the effective yearly rate, accurate to 2 decimal places for each of the following compounding frequencies. Show your calculations. No, they don't give us an amount that we start with, because that's not what we're looking for. We're looking for the percentage. But in order to make this simple on ourselves, let's pretend we have $100. Because if we have $100, whatever we get on top of that is our interest, right? Out of 100, if I get $102 after a year, that's 2% interest out of 100. So if we just say, let's start with $100 times 1 plus 0.07, right? Not 7, not 0.7, 0.07. Quarterly means 4 times a year. Once every quarter. So divided by 4, raised to the 4 times 1. We just want to know after a year, how much interest have I earned? Now I'm just going to give them all to you all at once. So the only thing that changes for part B, still $100, still 0.07%, but now monthly, that's 12 times 1 up in the exponent. And then daily, 100 times 1 plus 0.07 divided by 365 raised to the 12 times 1. Not 12, 365. Going too fast. 365. Try those. They should all be very similar, but not exactly the same. Most of your calculators, you can go back and edit it. You could just go into the same one and change the 4 to a 12, change the 12 to a 365. So you're good with this one. Just make everything at 5 feet. So far. As long as it makes sense to you. Just watch, make sure you're answering. And you're okay with this calculator as far as how it works as well. We'll get the logs on this too. That's why it's in the section. So put it all in like I've got there. You actually have to try it because essentially what happens is the bank pays you a little bit of your interest each time, but everything they pay you, they're also paying what they already paid. And so it goes up a little bit more each time throughout the year. So the more often you get paid, the more interest you actually end up with again. So I just try to make sure it's 0.7%. So if you put a 7 in there, it means they're giving you 700%. They're paying you 7 times what you start with.
It would be awesome, but nobody's gonna do that. Oh, yeah. Like I used it for yesterday. I didn't like that before. You know what, let me pop in my.
Okay. Everybody take a look. Eyes up here. This is what you get for each of these, but it's actually not your final answer. I need everybody's full attention so nobody makes this mistake. After a year of quarterly compounded interest, I have $107.19 in my bank account from my initial $100. What percent interest did I get? What's the actual interest here? How much did I start with? We were pretending I had $100. How much more did I earn? 7.19, and that's out of my $100. Percent is out of 100. This is 7.19%, essentially without the initial $100 that I started. That's how much interest I earned. So 7.19%, which means how much interest did I earn for the monthly one? 7.23%. And then for the daily, 7.25%. Now, if I extended this, what if it was not just I stopped at daily? I went to hourly compounded every second of the day, compounded continuously, milliseconds, nanoseconds. If you just keep going, that's what calculus is all about. Calculus is taking this pattern and saying, okay, what would happen if I didn't just chunk it into small pieces, but infinitely small pieces? I was doing it every moment. It was going on continuously. That's where the number E comes from, is this pattern. If I keep going, there is a way of finding that final answer using E. Does everybody see that it doesn't keep going up though? There is a limit, right? It's getting smaller and smaller amounts that we're going up. Again, that is all of what calculus is about, is taking this and finding what that answer would be if I kept going with that pattern. For number 3 then, just plug it in. This is exactly what we were doing. $2,000. 1 plus 0.02 divided by monthly. How many months in a year? You would be surprised how many people miss that. 12 for monthly, raised to the 12, put it in parentheses, times 15. Is everybody aware? This is saying if I get 12 months payment every month for 15 years, 12 times 15 is the total number of payments, or the total number of interest payments that I'm getting for this. Go ahead and try it. Your answer should be reasonable. If you get 2 million, something went wrong. If you get negative $5, something went wrong. And then parentheses. Or no, you start with 800. You may have to put time instead of just going straight to this. 1 plus 0, 2. Because I was watching, I did all this right, like 12. Got that. Yeah, I think you put the wrong starting number. All right. The answer, I'm seeing lots of you with this. What was it? Can we get a couple of you confirming? Is it 0.04? Right. All right. So again, 15 years, 2% interest, $700 for nothing, just leaving it there. Now, real quick, we had a question in the previous class. How does a bank make money? Like you put your money in there and they give you back extra money. What's going on? So let's say that Alyssa has $1,000 she's going to save. She puts it in the bank. The bank is required by law to keep a certain percent of that. So maybe they set aside $100 and say, okay, I can't do anything with this one, but the other $900. Ethan's going to go and buy a car and he's going to borrow some money. He borrows money from the bank to buy the car. And maybe some of that is the $900 from Alyssa's money. The bank tells Alyssa, I'm going to pay you 1% on the money that you gave me. So she's her $1,000, she's getting a 1% on that in her account. But then when Ethan borrows the money, the bank says, we're going to charge you 3% interest. So there's a difference. That extra 2%, the bank gets to keep. Does that make sense? That's how they pay their employees. That's how they pay for their building. It's how they pay for their software. If it's a for-profit bank, that's how they make their profit. Is the difference between the amount of interest they're giving to the people that invest money compared with the amount that they charge people that borrow money, which is why it's always you get less interest for investing than you get or than you pay for borrowing. Along those lines, so I said that they only keep a fraction of it. So if Alyssa wants her $1,000 back, the bank doesn't necessarily have her $1,000, but they have the $100 that they saved from her, and then $100 from another person. They have a certain percent of the money there in stock. And so if Alyssa goes and wants her $1,000, she gets $1,000 back, not necessarily her $1,000, but the $1,000 that they have there to pay her back. If you've watched Mary Poppins or seen like stuff on the Great Depression and you've got the run on the bank, if everybody wants their money back at the same moment, the bank doesn't have it. Does that make sense? They've got 10%. So if 10% of the people all want their money, they're okay. But after a certain point, they don't have the money there right then. They have to wait and they have to get it back from the people that are paying them back. This is why, if you pay attention, your bank is insured by the federal government. There'll be a little sticker somewhere in the window saying this bank federally insured by the FDIC. Couldn't remember. I'm one of the other people in the room in second period. Remember that I think it's like Federal Deposit. I'm not going to remember what it stands for. But they're insured up to a certain point. So they're like, any money that you deposit with us, the government backs that up to $1 million. So as long as you don't have more than $1 million in the bank, even if the bank collapses, everybody wants the money back at the same time. The government says, we'll step in and pay back that money. And then essentially we'll get the money from the people that are paying off their debt to the bank over time. If it's beyond that, whatever the insured amount is, technically that money's gone if the bank goes bankrupt. But again, for most people, that's never going to be an issue because you're not going to have $1 million or more. I forget what the maximum amount is in one bank at one time. Does anyone have questions about how that works? All right, let's do a few more. No, again, if you think of something, yes. Go ahead. And we'll talk a little bit more about interest rates, common interest rates, what it means, what it looks like, if there's time. Number 4, a person invests $850 in a bank that promises 4% compounded continuously. This is, again, without that second equation. How do I divide by infinity and multiply by infinity? I can't do that without calculus. Someone has done this work for you though. They took calculus, they learned calculus, they used it to come up with the P times E to the RT. This equation is essentially what you would get if you divided by infinity and multiplied by infinity where n was. P times E to the RT. Sometimes called the PERT equation. So let's plug it in. 850 times E, which if you're not sure where it is on your calculator, find the natural log button. It's almost always second or shift natural log. You'll find that E key raised to the rate as a decimal. So 0.04 times T. Here's an equation that will tell me how much money I have in the bank if I invest $850 continuously compounded at 4%. So they want to know then, how much is that worth after 20 years? Let's try it. 850 times E to the 0.04 times 20. Plug 20 in for T. Go ahead, try it. See what we get. Make sure your answer makes sense. No, you're gonna actually evaluate it with the calculator. It'll do E at 2.71 going on forever. It'll multiply that or raise it to the 0.04 times 20 power. And that will be your answer. Like you'll get a number that makes sense as far as money in the bank. Just put that in your calculator, it'll take care of it. That's okay. I appreciate you letting me know that you're going. And most times, so usually they've made eye contact with me and like said this, or some people like use a little T symbol and all those. And usually that's fine. I don't grow old enough to police it. There's only out of my 150 students, like 2 that cause problems. And there's not like 20. So then I talk with them like kind of so, but it's mostly for that and for if someone asks me, hey, do you know who's in the hallway at this point? But yeah, I have no problem with you going to nothing. You need to. You only go if you need to. So. How to put it in your calculator or what it means. So that E is essentially representing the continuously compounded. In order for me to truly explain where it came from, you have to take values. Right now, you kind of have to take me on faith saying that what they did was take that 1 plus the rate of 0.04 divided by infinity. If we cut it up with an infinite number of pieces and then raise it with an infinite number of times.
You can only go so far. It's going so big. Everything in the already is.
That's because those are atoms, and atoms can't be divided infinitely. Numbers can. And so we can calculate this. So just literally 850 times the ET. And so it's usually right above the natural log, so shift natural log, because they're related natural logs, log basis. And then put some parentheses. This calculator, I think, is going to do this, and it's already raised to power. I want to make sure it's raised to power. Parentheses. 0.04 times. See, if it's not happy, it's because it already raised to a power. So you can go. You want to say? It's already to the power. So a few of you, your E key is going to automatically raise to a power, and some of it won't. So let's try the 30x days again. I'll put it up here. And okay, if you're getting errors on your calculator, it's probably because your E key is already raising to a power. So again, this won't show up on the screen there, but if I were to do this one, 850 times, when I hit E, let's see here, where is it on this one? There it is. Does everybody see how it says E to the X power? So if I hit second E, it's giving me an error right there. So that means it's trying to do e to a power already. So in order for this to work, do the 0.04 first times 20. Do the exponent. Gets you 0.08. Now do the second e. There's the e to a power. And then multiply by 850. So you're going to have to put in the exponent first. You're going to have to do order of operations for it. Because as soon as you hit that e, it's trying to take e up to the power, whatever's on screen.
So this is your.
Yeah, that's 1,891. I'll show you. 1 second. This is new. So, anybody else having trouble with their phone or calculator, however you're putting it in? Did everybody get $1,891.71?
Yes.
Excellent. All right, everybody's full attention up here again. Something brand new. Brand new. If you've been paying attention, you may have noticed that this is the unit on logarithms, and we haven't seen logarithms show up yet. This is why it's in this particular unit. Up till now, you wouldn't have had a way other than guessing of figuring out when your bank account is equal to a certain amount. So we're going to learn that now. What if I wanted to find when my bank account would be worth $1,200? If I started with $850 compounded continuously at 4% interest. So I want to solve for t. T is in the exponent. This is why we learn logs, is to solve for exponents. So I can go ahead then and divide both sides by 850 to get the e to a power by itself. 1,200 divided by 850. Oops, 850.
1.4.
Oh, I didn't like that. That's interesting. Yeah, I think it's 1 point. Is it 1.4? Okay, so 1.41. Like, how far should we go here? 1.41 is probably good enough as long as that's the correct rounding. Equals e to the 0.04 t. So now I'm going to switch this to log form to get that t out of the exponent. What's log base e? How do I write log base e? ln, the natural log. Natural log of 1.41, so whatever it was equal to, that's inside my natural log, is equal to the 0.04 t. Divide both sides by 0.04. And this right here, that's your answer. Again, if I see that on the test, you've done everything correctly. That is correct. But I'd really like to know how long that is. Because let's face it, if someone asks you, how long is it going to be? And you tell them the natural log of 1.41 divided by 0.04. What does that mean? So try it. Natural log of 1.41 divided by, close that parenthesis before you hit divided by 0.4. 0.04, right? If your answer doesn't make sense, I accidentally put in 0.4. It told me it was going to be less than a year, 0.89, and I knew that was not right. So I checked, saw that I missed a 0, and fixed it. Your answer should be 8.59, about 8.5 years.
Did you close the parentheses after the?
Oh, actually, yours doesn't, yours may actually forgive you if you don't put in the parentheses. Try just natural log of 1.41.
Oh, okay, so then that's probably what it is. So natural log, okay.
Not quite. Sometimes it feels like it though.
So like that. And
Yeah, or if you want to be safe, hit equals. But try that. Try that. Yeah. So
I just divided it up first.
that particular calculator model guesses where you want the parentheses. Sometimes that's good, sometimes it's bad.
Yeah, I got 35 at first. Well, we are right.
So at this point, you have seen everything you need. If you want to start working on the homework for the last 5 minutes, you are welcome to do that. But before you do that, I have a couple real world questions for you. Anybody know what the percent rate is on the average credit card?
0.
No, wait, say it again.
That's if you like put your money in a bank.
Wait, say it again.
1%. So remember, credit cards are ways for other companies to make money. This is not you guys making money. Anybody know, anybody want to guess what the average rate is on a credit card?
Too much?
Closer. Very true. It's typically like 15 to 25%.
Not working.
So do not leave money on a credit card. If you check that, let's try it. Let's say you get a credit card, you buy something worth $200 and you leave that there for 5 years. How much do you owe? Let's try it real fast. $200. Let's do compounded continuously. So $200 times E to the 0.25%. Let's make it 25% interest, which is not unreasonable. There's tons of credit cards that are 25% or higher, times 5 years. How much do you owe? Like you could still get out of it, you could pay it, but that's a lot of extra money compared to the $200. What was it? 600, 700, 800, where is it? Okay, I'm hearing different answers. You've got 690, 690, $698 roughly. So you're looking at 3 times, more than 3 times the amount that you originally borrowed. So this is why, again, credit cards, okay, real quick spiel here. And if you take economics, you'll learn more about this. It's, yes, you do. So it's just when you take economics. Unless you take AP government, I think you can get out of it then. Do they do it both if you do that? Okay. So for this, I would encourage you to get a credit card. I would not encourage you to use that credit card because you're all probably going to have to borrow money at some point, whether that's to buy a car or buy a house. And the way they decide if a company or a bank wants to give you money is how you've done so far with the money that you borrowed. If you get a credit card, you buy something worth $50 every month and you pay that $50 off immediately. You pay no interest, none. But then when the company, that goes into what's called your credit score, the company can look and say, oh, every time you've borrowed money, you've paid it off. I'll loan you money because you've been doing well with the money that you borrowed. If you never have a credit card and you go to buy a car, they'll say, we don't know if you're going to be good with this or not, and either not give it to you or charge you extra interest for the privilege of them trusting you to pay it back. So having a credit card is great as far as building credit. You'll hear people use that phrase. It's not great if you buy stuff with it and don't pay it off. If you pay it off immediately, they charge you no interest. Pay it off once a month, just every day, every end of the month, the 30th, pay it off. You never owe interest on it. But as soon as you let it sit there, it builds up super fast. Any questions about interest rates, credit cards, loans, anything like that? All right, you guys can pack up or start on the homework 1 through 7.